Why is understanding operating systems crucial in computer science? Because operating systems are the backbone of any computing environment. They are the lifeblood that keeps our digital worlds functioning smoothly, managing the delicate dance between hardware and software resources. Delving into the heart of an operating system, we find key concepts like process management, memory management, file systems, and device management. Each plays a vital role in how your computer operates. Process management is all about how tasks are allocated and executed. Memory management is the art of storing and retrieving data efficiently. File systems organize and manage files and data, while device management ensures all your hardware components play nicely together. And let's not forget the principles of multitasking, multiprocessing, and multithreading. These are the gears and levers that make it possible for your computer to do many things at once, maximizing efficiency and performance. Mastering these fundamentals allows for efficient utilization of system resources and provides a solid foundation for the practical application of these concepts. Building on these fundamentals, we now turn to the practical application of operating systems in a lab environment. This is where the theoretical knowledge gained about operating systems is put to the test. Students roll up their sleeves and engage in hands-on exercises that range from system installation and configuration to shell scripting and automation, all the way to performance tuning and optimization. Take system installation and configuration, for instance. Here, students get to install various operating systems on virtual machines or physical hardware, tweaking system settings, network parameters, and user accounts as they go along. Shell scripting and automation tasks provide an opportunity to write scripts that automate routine system administration tasks like file management, process monitoring, and software installation. And through performance tuning and optimization, students use benchmarking tools and performance monitoring utilities to analyze system performance metrics and implement optimizations. Through these practical exercises, students become proficient in system administration tasks, troubleshooting techniques, and system optimization strategies. The culmination of this process is the application of these skills in collaborative projects and real-world case studies. This phase of learning is an exciting opportunity to put theory into practice, working in teams to solve complex problems using operating system concepts. Collaborative projects offer a unique platform to develop problem-solving skills, enhance communication abilities, and gain insights into the practical challenges of managing complex computing environments. For instance, one project might involve designing and implementing a distributed file system. This task requires students to apply principles of distributed computing and operating system concepts like process synchronization and inter-process communication. It's a hands-on experience that mimics real-world scenarios, providing invaluable insights into the workings of large-scale systems. These projects are not just about learning the technical aspects. They are about learning to work as a team, to communicate effectively, and to approach problems systematically. Through these projects, students not only apply their knowledge of operating systems, but also develop essential skills in teamwork, problem-solving, and communication.